So, welcome students, welcome to lecture number 18. So, we are slowly making progress into the main domain of how to use ML in materials engineering. So, we have been discussing about various algorithms, and as you know, algorithms are very important in the context of applicability. And I told you, right, the real challenge in making ML useful in materials engineering is basically how to develop new algorithms, and these algorithms comes from very simple concepts. The one I discussed in the last class was regression, and regression gives you numerical values of different output variables in terms of inputs, and this is naturally can be used in materials engineering, because regression is something which can be used for obtaining certain parameter, output parameter, when it depends on many input parameters like stress, or even you can think of elastic modulus. So, these parameters will depend on various input variables, and if we do not know what is the exact relationship, then we need to use data analytics. So, let us talk about some recap. So, machine learning workflow is like this. This is something which you have to remember all throughout this course. Either you need to get data from literature or you need to generate data. Nonetheless, data are key in your machine learning, and without that you can't do anything. So, everything depends upon how much data you have and how good they are. That means there are two aspects: number of data sets and the quality of data. So, number of data sets is obviously depends on how many experiments you are doing, or say how many data you can get from literature, or if you are generating data using some calculations or computer simulations, how many are available there. But if in some cases both are available in large number, then it is basically a boon for you. Now, quality of the data will not be as good as every cases. That is why you need to do data engineering. The next step is data engineering. That is what you are going to do, pre-process your data, and there are many techniques, so which we will discuss later part of this course. Then comes your model actually, and in the model you need to use some algorithms. Based on various experiences, you can either use one model or you can use multiple models if you do not have much experience in handling that. And once a model is trained, you can predict and you can do good predictions, you believe, then you have to validate your model. That means you have to validate your predictions with the experimental results, and finally if that is what is good, found to be good, then you can deploy the model. And this is something which is basically the total workflow of machine learning. You start with data and you end with deployment of the model in a real application, and therefore these are the 5 steps which we have discussed, and any model needs to learn or improvise for certain set of tasks with certain performances and keep on improve it. If it cannot improve, then there is no point in using the model. Okay. So, that is why your selection of model is going to be important. You have to see whether your accuracy and your predictive capability of the model is improving as you go on using it for certain set of tasks, well defined performances. So, we had already talked about this different kinds of learning, because learning is very important, because the machine is going to learn based on the data with some experience, right. That is what is machine learning is. So, supervised learning will develop some predictive model based on the both input and output data. For every input there will be a corresponding output data, and then supervised learning is good. But if it is not available, then you have to use unsupervised learning. So, we are only talking about supervised learning of late. So, we will talk about unsupervised learning later, then we will discuss about these techniques. So, let me carry forward. As you know, in supervised learning, normally we handle 2 groups of problems, and they are very important in material science and engineering. One is regression, which we have already discussed. Second one is your classification models. Classifications also can be widely used in material science. So, we talk about how it can be used later on, applicability. In fact, the TS will also discuss some case studies during live sessions when you will be learning this kind of aspects. So, regression, as we told you, is a very simple statistical model, and it utilizes one quantity variables or many quantitative independent variables to predict the dependent variable. So, what you need to find out the relationship, right, between these quantitative independent variables with the dependent variable. Y as a function of different kinds of x or x y z or x y z u v w, whatever number of variables you have, the relationships are important to be found out. That is what a regression does. And simple start with a linear model, linear regression. There you have no powers of x, you see all the x are with power of 1, and these beta 0, beta 1, beta 2 till beta p is basically our coefficients or weight given to each of these values of x in terms of very simplistic discussions. And still you can have still random error epsilon that needs to be optimized, and we have discussed how we optimize in the last lecture. We use a binary we use a quadratic error function or loss function, right. That is something which we already discussed. And in case of multiple regression, statistical model utilizes 2 or more variables. Basically that is more useful in material science, because we have many of these parameters like yield strength. It depends on so many things. Does it depend on grain size only? Answer is no. We know that quantity relationship between grain size and the yield strength, the classical relationship which is very widely used. Okay, yield strength is proportional to inversely proportional to square root of d. So that equation is only valid for certain set of materials, but if you have 2 phases, if you have many other things, then you need to use multiple variables to express the yield strength. And main caution is that you have at least 2 or more quantitative experimental variables. That is the rule of thumb. That means what? At least 2 variables should be used, if not more, and that is what is shown here. This is basically showing in 1 variables, but you can add that y depends on the x1, x2, x3, plus you can also have alpha 1, y1, alpha 2, y2, goes on alpha p, yp, etc. right. But here the way it is described, you do not need to do that. What it says is there are 2 slopes, beta 1 and beta p. Beta 1 is a slope with variable x1, okay, and beta p is a slope with variable xp. Then you do not need this thing. If you consider this a very equation, then you have to think about that this is not required. But suppose we consider equation in which y is a function of x, y both, okay, there are 2 variables, then y can be represented in 2 variables, because these can be considered as the values of x, x1, x2, that is how we defined in the last lecture. Similarly, for y we can define like that. And then you add an error, then it has become only 2 variables of regression equation. Remember, you need to know each of these alpha 0, alpha 1 to alpha p, and similarly beta 0, beta 1 to beta p. That is what you have determined, right. And if you want to do simple statistical roots, it is not easy to do. That is why you have to resort to computers. They can do it much better way. So the nonlinear models can be simply curvilinear, like either parabolic, hyperbolic, or many other things possible. It can be also logarithmic, we have discussed. It can be also square root transformations, or reciprocal transformations, or exponentials, all kinds of nonlinear equations possible. And material science exponential is very important. Many of these rate equations actually are governed by exponential terms, like Arrhenius equations. There are many actually. So therefore, this nonlinear regression analysis will be very useful in material science. Then we talked about classification. That is what we are going to focus today's lecture. So, machine learning task that deals with identifying the class to which an instance belongs to. This is nothing but a supervised machine learning method where the model will try to predict the correct level for a given input value. Correct level means correct answer. Let us say you are dealing with images, right, images of different animals, and once the machine learning model learns the images based on their attributes, okay, attributes can be shape, size, facial expression, many things. After that, if you provide a new picture, it must be able to classify that, it must be able to tell what this picture corresponds to. And in classification, model is fully trained using the training data, then it is evaluated on the test data before being used to perform the predictions or nuance in data. That is the normal thing. For typical classifiers I discussed, they can be the discrete values labels like age, marital status, health, salary, or it can be in bank, like you can give loans, which is perceptive inputs. It can be driving, and also, or it can be even what do I say, it can be even category of documents you can use like politics, history, biology, physics, or even test instance attributes, right. There are many such things, and because it is basically a task of classifying things into subcategories, that is what it is in a layman point of view. It is a part of any supervised machine learning. I am giving you point wise answer, bulleted points, and it is also a process of categorizing data or objects into predefined classes, which is already been trained. And main object of classifying learning method is to build a model that can accurately assign a level or a category to a new observation based on its value. So, as I discussed in the last lecture, the classification can be typically handled using the plants, and this is from a textbook of class 9 textbook of CBSE. Plants are basically classified using their characteristics. So, I do not want to go in details of this, I discussed in the last lecture. So, as you know, regression and classification, they are different, although they are coming in the same class of the supervised algorithms. Regression algorithms used to predict continuous numerical outputs, but classification algorithms used to predict categorical output. It does not talk about it can actually use for numerical output, but it provides categorical output like levels, and like algorithm can be used to predict whether an email is spam or ham, or is basically good email or bad email, that also it can be predicted. And as I discuss, I will talk about little more here. Classical classifications can be different types. First, let us talk about binary classifications. Here we want to classify input into two classes or two categories. To give an example, I show you two pictures, one a picture of a truck, other is a boat. Now, if you make your classification algorithm learn the whole thing's images properly, the moment you select boat, it will be able to tell you that it is a boat, it is not a truck. That is basically between two mobile devices. Truck can also be mobile and boat can also be mobile, right, and but they move on the different tracks. A truck moves on a road and boat moves on water. Now, we can also have classifications which are what do I say, multi classification methods. Okay, I think multiple classification method, that is something missing. Here you want to classify input into one or several class of categories. Okay, that is for example, on the basis of data, flowers, we have to determine which species it belongs to. Or if you give an example, let us say you have images of truck, plane and boat, right, and these actually are mobile devices. One moves on road, other one is on air, and third one is on boat. So, now if you have three or different, more than that, more than two images of particular things, and it has to select which one is what, then it is called a multiple classification, multi classification things. That is something which is routinely done in material science. When you have to classify different grains, let us say, how do you do that? This can be done using multi classifying techniques. Or you can also have multi-level classifications. What is that? Multi-level classification task, we have to predict 0 or more number of classes for each input example. In this case, there is no mutual exclusions principles. In the last class, there are mutual exclusive principles used, right, and because here there is no mutual exclusion principle used, the input example can have more than one level. What is what? Okay, I will talk about it. This has been observed in different domains such as auto logging, auto tagging or natural language processing NLP, where a given text can contain multiple topics. Similarly, to a computer vision, an image can also contain multiple objects. Let us take about this image. It has multiple objects. It has a truck, boat, plane and a dog. So, it must be able to tell which one is what, or it must be able to tell there is a boat on the right side, you see there is a boat here, then there is a cat, there is no cat, or this is a picture of a dog, and then you have a plane, and then you have also a truck, right. So, it has made a mistake by telling that there is a cat, basically it is a truck. So, this is just to elucidate that if learning is not proper, how a machine learning model can also make mistakes, right. So, it is one image, there are so many one particular picture, so many objects are there and it has to choose or it has to tell which object is what. That is what is called multi-level classifications. Here there are different levels in one image. There is a level of a dog, there is a level of a plane, level of a truck and level of also a boat, and it has to do that actually. So, that is why it says that it can predict 0 or more classes for each input examples, correct. And here you cannot use multiple mutual exclusive principle like what we used here. Here you are using mutually exclusive principles, the way the object looks like from one to other, that is what is called mutual exclusive principle. Truck will look distinctly different from a boat. So, easily it can detect that image carefully and store or get it trained, okay. But here it is cannot, because in the image itself everything is there. So, most algorithms used to those for standard classifications can be used for this multi-level classification, like multi-level decision trees, multi-level gradient boosting or multi-level random forest, they can be used, okay. So, therefore, there is not widely different things to be done when you want to use multi-level classification. But this again I taught, but it requires a good discussion here. You know, when we talk about learners, there are basically two types of learners we discuss. One is lazy learners. The learners will simply store the training data and wait until the testing data appear. But eager learners will construct a classification algorithm first based on the training data, and then it will give you predictions. So, lazy learners are what? One is, you know, we always tell this sentence to everyone that one is known by the company one keeps. The lazy learners, what they do? They are also called instant based learners. They do not create any model at all immediately from the training data, and this is where the word lazy comes into picture. They just memorize the training data, and each time there is a need to make a prediction, they search for the nearest neighbor from the whole training data and then make the prediction. That is why it takes less time in training but more time in predictions, because there is there is no model to be created, and therefore, the prediction is simply done by memorizing the training data, correct. So, when they want to recall the training data, if they want to search the whole training data, it will take a lot of time. So, what they do, they search for the nearest neighbors which are nearby. So, therefore, in a nutshell, lazy do not create a model at all. It do not create a model of training in advance. When instance arrives for testing, it runs the algorithm and gets the things. Example is KNN, we will talk about it, that K nearest neighbors. In fact, it is already told about you that how it searches for nearest neighbors actually. There are also case based reasoning which can also be used for such a kind of purposes. In contrast, eager learners is also I have written one is known by actions actually, and they actually machine learning algorithm that first built a model from the training data sets before making any prediction. So, first it will make a model unlike the lazy learners, and they spend more time during the training process because of the eagerness to have better generalization during the training. And then, so therefore, they require less time to predict, but they require more time to learn. But if you will ask me, eager learners are much better in terms of predictive capability, but they takes time to learn because it has to undergo training. Eager learners develop a classification model based on the training data set available, and in fact, before they receive a test data set, it learns very nicely, and it takes more time in learning. That is why it takes less time in prediction. It is exactly opposite in lazy learners. They take no time in learning, but they takes more time in predictions. Logistic regression, support vector machine, decision tree and artificial neural network, they are the examples. And as you see in material science, these are the ones which are widely used. KNN used, but KNN is not so widely used. DT, SVM, LR or ANN, they are more widely used in material science, because we are more inclined to first build a model before predicting, because our data sets are like that. But in business, or in case of let us say Swiggy or Zomato's, they will rather use more lazy learners, because they have to predict, they do not have time to learn much, or their data sets are like that, they do not need to learn much, and they can predict from the nearest neighbors. That is what they do. Very simple example is that let us say food has to be delivered by somebody and to a certain address. So, what is the shortest route to follow? Okay. Many of you use Google to do that, but Google uses similar kind of learners. What do you do? Classification learners, and choose these things, but on the top of which they also look at traffic situations, and based on that they calculate the time. So, these are built in your mobile phone devices. So, in a nutshell, classification algorithms can be many actually, starting from logistic regressions, DT, KNN, support vector machines, and some of the base learnings, right, naive Bayes, and for lastly stochastic gradient descent models. Okay. I do not think I will be able to talk about all of them, but definitely I try to discuss most of them. But classification requires a 2-step process. Obviously, first is model constructions, and each sample is assumed to belong to a predefined class, and that determined by the attribute or features of that class. Like if you have a dog, the features of a dog will be its face, its size, and even color, all these things. So, this set of instances, a sample or model is always called a training set. A model is represented by certain classification rules, which we will just discuss in the next part of the lecture, decision trees or mathematical formulae, and model is used for classifying things for unknown objects. So, you have to estimate the accuracy, and you also estimate how fast it can do, and that is what actually is will be discussed later on. So, let us give an example of model constructions. Let us talk about a training data like this. There are set of people, I given names, they have different ranks, assistant professor, professor, associate professors, and how many years they have spent in the system, and then the output is whether they are tenure or not. So, this is what is fed to the classification algorithm, and then if you gave a data of somebody and ask whether it is a professor or not, whether he has spent more than 6 years or not, then it has to give yes. That is what it is. It is very simple, and it can also predict, as you see here, as you clearly see that George is a professor, Joseph is not a professor, even though he has spent 7 years time. Both of them spent 7 years times, but one is associate professor, other one is a professor. But on the other hand, George has spent only 5 years as a professor. Therefore, tenure does not depend on what rank it is, it depends on how much time one has spent. That is what it is. So, that is what the model prediction is. All better way of giving these examples is the data sets of weather parameter. Let us talk about, there are 14 days, you look at the weather outlook, sunny, overcast, rainy, okay, and temperatures can be hot, mild, cold, humidity can be high, normal, or even high and normal, wind can be strong or weak, and therefore, then you will make a decision whether you are going to play tennis or going there or not. How can we put this as a decision tree? Well, very simple. First thing is outlook. If it is sunny, it can be sunny, overcast, rainy. If it is sunny, it can be humidity can be high or low, high or normal. High humidity means do not play, because you will sweat hard. Humidity is low or normal, it is okay, you play tennis. If it is overcast, you always play tennis because there is no sun, then you will not feel hot, right. If it is rainy, still you can play, if the wind is weak, in tennis, but the wind is strong, you can't play tennis. So, that is how we put all this data which is available data sets into a decision tree. Okay. You can clearly see there is a root and the tree develops like a trunks. So, we will talk about all these aspects in more details in the next part of the lecture, and decision tree is a very important concept. So, let us hold on.